Hi, today we're going to go over SpringBoard, lesson 30-3, multiple transformations of the quadratic parent function. Okay, and so let's go ahead and get right to it. And so we'll start off with learning targets. The learning targets are graph reflections of the quadratic parent function, identify and distinguish among transformations, and compare functions represented in different ways. Number one, the quadratic parent function f of x is equal to x squared is graphed below. Graph g of x equals negative x squared on the same coordinate grid. And you can see it's already done for you. Right here, in black, this is going to be our quadratic parent function that we're used to. And when we go ahead and we graph g of x is equal to negative x squared, we see that it is reflected across the x-axis. Compare g of x and its graph to the parent function f of x is equal to x squared. As I indicated, it is reflected across the x-axis. What that means, though, is when initially it was opening upward, or like I like to call a happy flower, now it is opening downward, which I like to call a sad flower. Sad flower. All right, so that's the biggest difference. It looks like everything else is the same, except for our outputs are their opposites. So 0, 0, 1. If I plug in a 1, it'll output to a positive 1. But if I plug in a positive 1 on g of x equals negative x squared, then it's going to be a negative 1. Okay. What's important to understand here when you're working with this g of x is equal to negative x squared is, according to orders of operations, we do the exponent first, x squared, and then we apply the negative sign to it. So this is like negative 1 times x squared. We would do the x squared first, and then we would apply the negative 1 to it. The change to the parent function in item 1 is a reflection over the x-axis. A reflection of a graph is a mirror image of the graph over a line. A reflection preserves the shape of the graph. Okay, so remember, reflection does not change the shape. Number 3, how does the sign of a in the function g of x equals ax squared affects the graph? And again, what happened was before we had f of x was equal to x squared, which we could say the coefficient of x squared was positive 1 and opened upward. And so when g of x was negative x squared, it was really a negative 1 was the coefficient of the x squared, and it opened downward. So the sign of function of a, of course, will determine whether it opens upward or whether it opens downward, or whether it's a happy flower or whether it's a sad flower. A graph may represent more than one transformation of the graph of the parent function. The order in which the multiple transformations are performed is determined by the order of operations indicated in the equation. How is the graph f of x equals x squared transformed to produce the graph of g of x, which is 2 times x squared minus 5. All right, so again, we're using this in orders of operations. And so what will happen here is we'll of course do the exponent first. So we're going to graph the parent function x squared, okay? And then we're going to go ahead and do the multiplication. So we're going to apply the stretch factor of 2 to change how wide it's opening, okay, or how narrow it's opening. In this case, it would become more narrow. And then we're going to do the translation. In this case, we're going to move this particular function down 5. So we'll go ahead and look at item number 5. It says, use the transformations you described in item 4 to graph the function g of x is equal to 2 times x squared minus 5. And you'll see that, again, the parent function would have been right here, and I'm just kind of showing it to you because I don't want to draw it on there. And what you'll see what will happen is the first thing we did is we said, okay, we'll start off with the parent function, and then we'll apply the stretch factor of 2, which made it more narrow. And you can see on the new graph, if we just kind of thought if we moved over 1, we're now going up 2 instead of 1 to 1. And so we applied the stretch factor first, and then we translated it down from the origin, 1, 2, 3, 4, 5. Item number 6, how would you transform the graph of f of x is equal to x squared to produce the graph of the function h of x is equal to negative 1/2 x squared plus 4? All right, and so we'll do these in orders of operations. So the first thing we would do is we would think, okay, we're going to start off with the parent function. So we're going to do something like that. Okay, that is way too big, but it's going to be something like that. And then we're going to go ahead and apply the in this case, the shrink factor of 1/2. So that's going to make it wider. And so I actually have already kind of made it wider on there. So we're good there. And then we have a negative sign here, which is going to flip it. It's going to flip it over. So it's going to take this that we drew here. I'm going to draw something very similar to it down here. Okay, so like that. And then, of course, the last thing we're going to do is we're going to move it plus 4 or up 4. 1, 2, 3, 4. Okay, and that's how we're going to do that. Okay, so we're doing these using orders of operations. Let me just recap. We're going to start off with the parent function x squared. Then we're going to apply a shrink factor of 1/2. And then we're going to do the negative sign. Okay, so the negative a is going to flip across or reflect across the x-axis. And then, of course, we're going to do our plus 4, which means we're going up 4 units. Now, the last thing it asked us to do on item number 7 is to identify the vertex and the axis of symmetry of the parabola. This is, of course, the h of x. So the vertex is going to be right here. It's going to be at the maximum value of this graph. And, of course, that's going to be at the point 0, 4. Okay, 0, 4, that's going to be the vertex. The axis of symmetry is going to be the vertical line that goes through the vertex. So in other words, it's going to be x equals whatever the x value is of the vertex. In this case, it's 0. So that would be the axis or line of symmetry. All right, so item number 8. How would you transform the graph of f of x equal to x squared to produce the graph of the function k of x is equal to negative 1/2 parentheses x plus 4 squared? So in this case, again, we're going to follow the orders of operations. So we're going to start off with figuring out what x plus 4 squared is going to be, because we'll always do the parentheses first, but there's really nothing we can do there. And then we would do the exponent squared. But remember what this transformation is. This transformation is a horizontal transformation. And remember, you go the opposite of what number you see here. So if it's a plus 4, that means we're going to go to the left 4. So we're starting off with the parent function, and we're going to the left 4. And then we're going to go ahead and apply the vertical shrink of 1/2. Okay, so it's the vertical shrink, and that's going to make it wider. And then we're going to apply the negative sign, which is going to go ahead and reflect it across the x-axis. All right, so let's go ahead and look at it in item number 9. Looking at it in item number 9, it says use the transformations you described in item 8 to graph the function k of x is equal to negative 1/2 x plus 4 squared. All right, so we're going to go ahead and do that. And if you notice, the first thing we do on here is we start with our vertex being at the origin, and we're going to move it to the left 4. Okay, then we're going to square it. The square it just makes it a parabola. Then we're going to apply the stretch factors, the shrink factor of 1/2. And remember, a shrink factor of 1/2 makes it wider on here. So if you remember from the parent function, we can just kind of pretend that's what this is. If I went over 1, I'm only going up 1/2. Okay, over 1, up 1/2. Okay, if I'm going over 2, 1, 2, then I'm going up 2 here. Okay, so it's 2 and 2, so on and so forth. So it's wider now. The parent function would have been something like this. And then the negative sign is the last thing we're going to do. It means we're going to reflect it across the x-axis. So we started off with something like this. and then we're reflecting it down across the x. All right, so the vertex is the point after the translation. The x value is now -4, and the y value is 0, okay, because we only translated it horizontally. We did not translate it vertically, and your vertex moves based on the translations. All right, and then our axis of symmetry, which is going to be the line that goes through the vertex. It's a vertical line going through the vertex, so therefore it's going to be the same as the x value, so it's going to be x is equal to -10. Reason abstractly. The graph of g of x equals a times x minus h squared plus k represents multiple transformations of the graph of the parent function f of x equals x squared. Describe how each value transforms the graph of g of x from the graph of f of x. Item A, value k. K represents a vertical translation, where if k is positive, the translation is up k units. If k is negative, the translation is down k units. Item B, h. H is a horizontal translation. Because of the negative sign, if h is positive, then it's going to end up being negative h, which means it's going to move to the right, h units. If h is negative, then you're going to have minus a negative to give you a positive h, which means it's going to move to the left. C, the absolute value of a. The reason why I say an absolute value of a is because we do not want you to consider the sign, just the value of a. If the value of a is between 0 and 1, then that is going to be a vertical shrink, which is going to make the parabola open up wider. If the value of a is greater than 1, it is a vertical stretch, and that's going to make the parabola open up more narrow. D, the sign of a. This is whether it's a negative sign or a positive sign. If it's a positive sign, then which means it'll continue to open upward. If the sign is negative, that tells it to reflect across the x-axis, and now it will be opening downward. Item 11, examine the function r of x equals 2 times x minus 4 squared plus 3. So we're going to describe the transformation from the graph f of x equals x squared to the graph of r of x equals 2 times x minus 4 squared plus 3. So using orders of operations, we're going to take care of the parentheses first. And that's going to tell me to do a horizontal translation to the right 4 units. Okay, so we're going to starting at the origin here, we're going to go to the right 4 units. All right, and then the squaring of it tells me that is a parabola. And then we're going to apply a stretch factor of 2, which means it's going to be narrower. All right, and then after we do all that, then we'll go ahead and move it up 3. So let's go ahead and look at the graph and see how that worked out. So we start off with the parent function. Remember, the parent function goes something like this. And so the first thing we're going to do is we're going to move it to the right 4. So we're going to move it 4. We're going to put it right here. Okay. And then we're going to apply a stretch factor of 2. So we're going to basically multiply all of our outputs by 2. Okay, so instead of it going over 1 and up 1, we're going to go over 1, up 2. So, and then the last thing we're going to do is we're going to move it up 3. 1, 2, 3. So number 3, identify the vertex and the axis of symmetry of the parabolas. Of course, the vertex is going to be based on the transformations. It changed to the right 4 and then up 3. And so going from 0, 0, moving over 4 and up 3, our vertex is going to be the new ordered pair 4, 3. And remember, our axis of symmetry is going to be the equation where x is equal to the x value of the vertex. Item 12. The vertex of the graph of f of x equals x squared is 0, 0. Describe how the transformations can be used to determine the vertex of the graph g of x is equal to a times x minus h plus k without graphing. And again, I've indicated a couple times that your vertex is going to be based on your transformation. So if we think about what's going on here, we're transferring this, because it's a minus sign, we're transferring it positive h units, and that's going to be our change in x. That's going to be our side-to-side change. So it's going to be a positive h units because it's a negative sign there. All right, and then we're going positive k, up k units. So our vertex in this case is going to be hk. It's going to be those values that we're transforming. Identify the vertex of this graph, y equals 3 times x minus 4 squared plus 7. So in this case, again, because it's a minus sign here, it's going to be the opposite of that. So it's going to be a positive 4. And then this one, we keep the sign, it's going to be a positive 7. So it's going to be 4, 7. All right, so let's go ahead and look at some of the check your understandings on here. All right, item number 13. Without graphing, determine the vertex of the graph of each function. Okay, so as we look at A here, we're looking for the change in x. In this case, there is no change in x. There is no change in x, and so therefore it's going to stay 0. That's what it was before. We're going to stay 0. All right, and of course the plus 6 means we're going to go up 6, or my y value is changing by a positive 6. Okay, item B, y equals 3x squared minus 8. So remember, the coefficient does not change its position. It just changes the how wide or how narrow the opening is. So we kind of ignore that for this situation. We don't have the x, we don't have anything being added to the x before it's being squared. So therefore, this one is going to change horizontally, or in the x direction, by 0. And in the y direction is changing down 8, or in the negative direction, 8 in the y. So our vertex is 0, negative 8. All right, so C is y equals x minus 4 squared. So in this case, we are changing the x value by negative 4, but remember, we're taking the opposite sign. Negative 4 means we're moving to the right 4, in the positive direction 4. And then now here we don't have anything. We could put a plus 0 if we wanted to remind us that we're, of course, moving it in the y direction, up and down. We're not moving it at all, so the change is 0. D is y equals x minus 2 squared plus 1. So again, we're doing the opposite of that negative, because when I have a minus 2 here, I'm going to the right 2. So that's going to be a 2. And then the plus 1 means I'm going up 1. I'm going in the y direction, positive. All right, and then the last one is y equals 2 times x plus 2 squared minus 5. And again, we don't worry about the coefficient, what's outside here. We don't worry about that yet as far as finding the vertex. We just look at the change in x. So x is changing to the left 2, or in the negative direction. And then we're going down 5. So in the negative direction 5. Example A, for the quadratic function shown in the graph, write the equation in standard form. Okay, well, first of all, we want to make sure we understand what we're doing here. What we've been working with today is the equation in vertex form. And in vertex form, that equation is y is equal to a times x minus h squared plus k. That's in vertex form. And the reason why it's called vertex form is because we can easily see the vertex being the values hk. All right, we want to convert it to standard form, which of course is y equals ax squared plus bx plus c. Okay, so we're gonna do this conversion during this process. So the first thing I want to know is, in order to use this vertex form, I need to use the vertex, and we notice the vertex is sitting right here at the value -1, +1. So the vertex here is equal to -1, +1. So if we look here, we have the vertex, we have another point, and then we have A. If I'm trying to solve for A, I need another point. Well, I like to use a intercept if I can, so I'm going to use the y-intercept. All right, so the y-intercept is equal to, or is at the point 0, 3. That's the y. And now I'm just going to plug these 2 points into the vertex equation. So it's going to be 3 is equal to A. A is the unknown value, times x, which is of course going to be 0, minus a -1, because that's the h value. And we're going to square that, and we're going to add a +1 to it. And now we can just go ahead and do the work. So we have 3 is equal to A times a +1 squared, is negative is +1 squared, plus 1. Of course, we know that +1 squared is just 1, and 1 times A is just A. So we have 3 is equal to A plus 1. and then we subtract 1 from both sides, we get a is equal to 2. So the neat thing about that is once I have the a value, now I can go back to the vertex form and plug it in, but leave the x and y blank, and then we have the equation written in vertex form. So the equation written in vertex form is going to be y is equal to 2 times x plus 1 squared, and then that's plus 1. Now you may be wondering why I put a plus 1 here. Remember that should have been x minus a negative 1. And so I just kind of did that step ahead. So now what we need to do is convert this to standard form. And so we have it as y by itself already. We just need to simplify these other numbers. But what you'll notice here is that we have this x plus 1 squared. Now that is a special product. That is a binomial squared. And so we can go ahead and do that using a formula chart, or we could FOIL it if we wanted to. So that's going to be y is equal to 2, and then we have this binomial squared, and that becomes x squared plus 2x plus 1, okay? And again, remember it's 2x because the formula chart says so. It's x squared, all right? And then the third term squared is there. And then it's going to be 1 times x, which is x, and then double, it's going to be 2x, and that's how we get our middle term. And then we're going to add 1. Now notice I left it in parentheses, and it's important because that whole thing was multiplied by 2. So we're going to have to do that. So y is equal to 2x squared plus 4x plus 2 plus 1. And so we go ahead and combine like terms. Y is equal to 2x squared plus 4x plus 3, and that ends up being our answer. Try these A, and I'll go ahead and clear this off here. Let's try these A. So we're going to do the same kind of thing. We're going to write this in standard form. It's given us 2 points on here, so we don't have to worry about that. So we'll start off with the writing it in vertex form because we have the vertex and one other point. So we'll go ahead and do that. Remember the vertex form is y is equal to a times x minus h squared plus k. And we simply plug in the 2 points here. The vertex is this one right here. So it's going to be, the other point we have is negative 1, 1. So it's going to be 1, the y value of the other point, the non-vertex. And that's equal to a, which is what we're solving for. And then the x value of the other point, negative 1. And then we have minus x value of the vertex, which is going to be negative 2. They're both negative 2, but there you go. We're going to square that, and then we're going to do plus or minus 2. Okay? And I separated those out like that. You can sometimes go ahead and do both steps together when you have practiced this enough. So let's go ahead and kind of simplify this down a little bit. That's going to be 1 is equal to a times negative 1 plus 2 squared minus 2. And then negative 1 plus 2, which would, of course, be a positive 1. All right, positive 1. And so positive 1 squared is going to be 1. And so that's going to be 1 equals a times 1, but that really doesn't matter at this point. And then minus 2, then we add 2 to both sides, and we end up getting 3 equals a. So our a value is equal to 3. All right, so when we put that back into the vertex form, we're going to now have y is equal to 3 times x minus a negative 2 minus 2. And again, I put the minus 2, it's plus a negative 2, which is minus 2. Probably could have done the same thing here. Y is equal to 3 times x plus 2 minus 2. Don't get it squared. And so what's important to remember this is sometimes we're going to be pulling the vertex out of this. And so remember your vertex is going to be the opposite of the sign you see here to get the negative 2. And the actual sign that you see here to get the negative 2. That's kind of an important thing to remember there. All right, so let's go ahead and continue working with this. Remember that we have this square of a binomial that we have to work with. And so that's going to end up being y is equal to 3 times, and again, it's going to be the first term squared, and then at the end, the last term squared. 2 squared is 4. And then we multiply 2 times x, which is 2x, and then double it, it's going to be 4x. And then, of course, we have minus 2. And then we're going to distribute the 3. Y is equal to 3x squared plus 12x plus 12 minus 2. And then combine like terms. Y is equal to 3x squared plus 12x plus 10. And that would be your equation in standard. Try these A, item B. We want to write this in standard form. But looks like we only have 1 point, but we have grids behind it. So we have as many other points as we need. And so in order to be able to do this, I'll need the vertex and one other point. And I'm just going to pick this one right here, okay? I'm going to pick this point right here because it's nice and pretty on there. That looks like it's going to be a 3, 4. And so now I'm going to go ahead and do that. So I'm going to start off my vertex form, which is y is equal to a times x minus h squared plus k. And I'm going to go ahead and plug in these 2 points, okay? So first of all, my y value of my second point, so it's going to be a 4. All right, it's going to be a 4, and that's equal to the a that we're looking for. We've got to find the a value. And then the x value of that point, which is a 3, minus the h value, and the h value, of course, is the x value of the vertex. So that's going to be a positive 1, okay, squared, and then the y value, which is, or the k value, which is the y value of the vertex. And so that's going to be a 2. Then I can go ahead and solve for a. Again, you could use nsolve if you want on here, or of course you could go ahead and do the work. And we're gonna do the work here. So we'll kind of cut it down a little bit as we talk about it. That's going to be 3 minus 1, which is 2, and then 2 squared is 4. So it's going to be a times 4. All right, a times 4 plus 2. All right, so we can go ahead and subtract 2 from both sides. Subtract 2 from both sides to get that. So it's going to be 2 is equal to 4 times a. Again, I just switched them around. We divide both sides by 4, and I'm getting 1/2. So a is equal to 1/2. So we'll go ahead and write that in vertex form. This time we're going to write the equation, which means we're going to leave that other point off. So it's going to be y is equal to 1/2 times x minus 1 squared plus 2. All right, and remembering our vertex is the opposite of the sign, so it's positive 1, positive 2. All right, so now all we have to do is go ahead and rewrite this in standard form. So of course we'll start off with understanding that this right here is a binomial squared. We'll go ahead and use our formula chart, or just remembering how to do this. So we're going to go ahead and do that first. So it's going to be y is equal to 1/2, and then we're going to go ahead and say, well, the square root, or the first term squared is going to be x squared. Then the last term, the negative 1 squared, of course, would be a positive 1. All right, and the middle one is negative 1 times x, which is negative x doubled. So it'd be negative 2x, and that's always a plus 1. And then we're going to go ahead and put plus 2 there. And then we're going to distribute the a value. Distribute the a value. So we end up with y is equal to 1/2 x squared minus 2x. So now it's going to be half of 2x. So that's going to be a negative 2 times 1/2, or half of negative 2, which is just going to be a negative x. And then we have plus 1/2. Okay? And then plus 2 at the end. So then we end up with y is equal to 1/2 x squared minus x plus, of course, 2.5. All right, 2 and 1/2. And just for fun, we'd also like to make sure we keep this as a fraction. So you would actually write this as y is equal to 1/2 x squared minus x plus 5/2. The vertex of a parabola represents the minimum value of the quadratic function if the parabola opens upward. The vertex of the parabola represents the maximum value of the quadratic function if the parabola opens downward. In other words, it's going to be either our minimum or our maximum, okay? Our minimum or our maximum is what it's telling you, and that's what we're going to call the vertex. All right, so moving along. Item 14, make sense of the problems. The equation and graph below represent two different quadratic functions. Okay, so they're not the same. This is not the graph of that function. Okay, so that's kind of what we're wanting to know here. Which function has a greater minimum value? Justify your response. Okay, so what we want to do is we look at this first graph and the second graph, and the minimum is based on our vertex. So we go ahead and look at our function 1, and we look at that and we say, well, what is the vertex of that one there? So the vertex of this one here, the input value is not changing, so that's going to be 0, and that's going to be -3. 0, -3 is going to be the vertex of the first one. The second one has a vertex of 0, +3. All right, and it wants to know on here, the question that's being asked is, which function has a greater minimum value? Well, they're both opening upward. We know the first one is opening upward because it has a positive a value. The positive a value be, in this case, of course, would be a is equal to +1, because the 1 is implied. The next one, of course, we can see that it's opening upward. So they both have minimum values. And so the question here being, what is the greater minimum value, would be the minimum value of the y value that has the highest number. So that's, of course, going to be this one right here, the graph, where it's a +3. Item 15. The verbal description in the table below represents two different quadratic functions. Function 1. The graph of function 1 is the graph of the parent function stretched vertically by a factor of 4 and translated 1 unit up. Function 2 is this graph here. Which function has a greater minimum value? Justify your response. Okay, so what we want to do is we want to look at item number 1 and try to figure out what the vertex is. From the parent function, it's based on its transformation. So the graph of function 1 is the parent function stretched vertically by a factor of 4. Well, that doesn't change anything, and translated 1 unit up. So we just went 1 unit up, so it's going to be, in this case, it's going to be 0 and went 1 unit up. So the minimum value in this case here is going to be 1. If we look at the table here, we notice that the vertex is at -3, 0. -3, 0. That's going to be where the vertex is. -3, 0. And I can tell that by its change in directions. And so the minimum value in this case is going to be 0, and the minimum on this one is going to be 1. Remember, the stretch factor does not change the vertex or whether it goes up or down. Okay, I'm going to leave the check your understanding and the practice problems for homework for you. Remember, if you have any questions, you can come to tutoring every day, Monday through Friday at 3 o'clock on Zoom. So hopefully I'll see you there. If not, goodbye.